So thank you very much, Bettingala, and a warm welcome to our audience to the Knowledge Cave, really a forum that gives us an opportunity to have conversation on thematic issues that are trending and inform key decisions in the country. And today we are here to talk about mathematics. We have been talking about finding X for a long time. I don't know whether we have ever found X. And we need to ask ourselves whether are we going to find X or we should stop finding X. And so our panel of council of experts will be here to help us to see, to unpack this paradox. As you guys are aware that the government has been rolling out the competency-based curriculum, which really is informed by the need to have a learning that is more focused on skill. And so the need, therefore, to have a conversation as to whether some of the core subjects that have been, that have been compulsory over the years might need to be upheld or not, has really been on the headlines. And this is why we are here on why mathematics, should it be optional, or should it continue to be compulsory, or could there be a compromise? And this is the paradox that my panelists counsel. They say that when you are caught with a paradox, you seek the counsel of the wisdom, right? So we have the counsel of the wise, comprising of Dr. Mary Ochieng. Dr. Mary Ochieng is a mathematics educator, a senior lecturer at the Institute of Mathematical Sciences at Strathmore University. And she is the director for the Research and Graduate Training Institute of Mathematical Science. She holds a PhD in mathematics, mathematics education, and a master's degree in social science. She's also the current chair of the Africa International Commission of Mathematical Instructions, if I got it right, isn't it, Mary? Thank you very much. You may want to wave to the audience. You're welcome. The next is Dr. Mary Sichangi, who is a senior also a senior lecturer in mathematical education. He's a mathematics education expert with 30 years of experience in conducting research and training in Africa. And she also holds a ministerial appointment in coordinating policy dialogues and forums in policy matters, and is an executive member of the Continental Network of the African countries with interest in STEM. She holds a Doctor of Philosophy in Education and Communication and Technology from the University of Nairobi, and is very passionate about STEM education. Welcome, Dr. Mary Sichangi. The third is Dr. Alice Karuri, who holds a PhD in Development Studies from Jomo Kenyatta University of Agriculture and Technology and an MA in International Affairs from George Washington University in USA, and also has a stint in economics from Morgan State University in USA still. Prior to joining Strathmore University, she was an adjunct faculty in various universities and has vast, extensive work experience in non-profit sector and research. She brings a lot of experience in policy analysis and expert assessment, evaluation, and intervention, as well as institutional arrangement. You're welcome, Alice. Then we have the last but not least, Dr. Florence Nyamu, who is a lecturer of Kenyatta University and a senior lecturer at the Department of Educational Communication and Technology, the School of Education of Kenyatta University. Dr. Nyamu has been a member of council member of various universities, and from Kabianga University, she was the chairperson of council. Taita Taveta University, she also served as a member of the council, and also she was a member of the council for Moi University. So she's really served at the highest ranking levels of the university. She's she has interest in gender and has worked for Forum for African Women, that is FAWE, a Pan-African non-governmental organization that has a commandate for promoting girls' education. She has a very strong passion for mathematics and its teaching and the pedagogy around it. She has worked in the East African Examination Council and Kenya National Examination Council between the 1977 to 1984. So really, dear audience, I'm surrounded by mighty wings, and I think if there is any conversation around mathematics, this is where we should be. And I just want to start this conversation by each one of you, in terms of you telling us your journey. How has your journey been at a personal level and at a career level, and how has mathematics informed it? Mary.
Thank you. Thank you, Dr. Saoke. My journey this far, I think my journey this far really has been motivated by a passion for mathematics and a passion to see it being taught well and in a way that would nurture not only future mathematicians, but people that have an appreciation for it as a discipline and people that are able to apply it to their day-to-day lives. And my journey started off career-wise as a high school teacher, but often just the challenge of performance that is not good, that really pushed me to seek further training, as I often was asking, what is it about this discipline that I'm so passionate about that makes it challenging for students? And that pushed me to pursue training, further training in mathematics education, and just to explore what are some of the things that need to be done to make the subject more enjoyable for students, but also to make it more accessible for them. So my journey this far has really been driven by seeking ways of making the subject more accessible and more engaging for learners. That is what has driven my journey to this point. And as you stated when you were introducing me, I am part of the AFRICMA, which is an affiliate organization of the International Commission on Mathematical Instruction. And really that organization seeks to promote mathematics education on the continent. Thank you.
Thank you very much, Dr. And just going to Dr. Alice, the same question, how in your personal journey and also in your professional journey, how has it been and how has math shaped it positively or negatively?
Okay, thank you. I think we might be the only social scientists here. So I'm surrounded by the math heavyweights. So basically, without giving my age, I grew up in a time when headmasters would come with a stick and you'd have to do the multiplication tables. And if you didn't answer fast enough, you got smacked. So that's the era I grew up in. And we had Friday rally tests. And I remember we had a teacher, a math teacher. So if you got below 50%, you know, he'd call out your name and give you the paper. If you got below 50, he'd throw it out the window. And you had to run out and get it and then come back. You know, so of course the person with the 5, you know, he'd have shut the door. But luckily I was good in math and it came naturally. So I never had to struggle and I didn't understand the struggle of it until I got to high school. And then coming from an A, you find that you're struggling. So it could have been the pedagogy, but looking at the statistics, you have like 80% of students in primary school get between A and B+. Then coming out of high school, it's less than 20%. So we have that disconnect. So moving to college, I wanted to do journalism, and that's what I did for 1 year. And then I got a professor of economics who convinced me that I needed to be more valuable in Africa as an economist. So I changed that and then now had to switch again and do all the other math courses. So it has really been instrumental, especially in development. It's a multidisciplinary course. We have to look at impact evaluations. We have to look at indicators. And there's so much, we have to look at regression analysis. So even though economics is considered a social science, we still rely on math a lot, especially now that we need evidence-based policies, evidence. So everything is coming down to numbers. However, I might not hold it in the same way, perhaps, as we continue our conversation, but definitely it's been integral.
Same question to Dr. Nyamu.
Thank you very much. Good afternoon. My name is Dr. Nyamu Florence, and as you were told, I teach at Kenyatta University. My journey with mathematics started when I was in grade 3. I went to a primary school in Nyeri, Udaya, and the beginning was that I did so well in grade 3 that I got a pencil as something to motivate me. And that was a big excitement for me because even affording to buy a pencil was difficult. Then in grade 6, a headmaster came who had just graduated from Kagumo Teachers Training College, which was a very good college at the time. And he was very passionate about mathematics. So he was very happy that I was performing well in mathematics. And he called me out one time and he said, Wawetima, that's my Kikuyu name. I think one of the girls we can take to Alliance. I had no idea what Alliance was. And I would like you to keep working hard and perform well. He was teaching us English and also mathematics. And he bought for me, for mathematics, a revision book. That motivated me. And I worked hard. I got the grades he wanted, and he used to beat us. If you miss the test by 10 marks, you get 10 slaps on the hand, you know, the stick. So he was tough, but he meant well. So I passed well, and that time I did, it was what was our exam? Kenya Preliminary Examination. Actually, Kenya African Preliminary Examination, KAPE, which was marked in England at Oxford. And when the grades came, I had passed well in both mathematics and English, not very well in the social sciences, which is okay. And I was actually admitted to Alliance Girls High School. So I remember that with a lot of passion, that as a teacher, what you tell your learners, if you encourage them, it becomes. Because for me, Moses' word became real. So at Alliance Girls, I met a very good teacher also. I remember Miss Shelby Gadua, she's still there in Nyeri. She came for teaching practice. And that she made it clear how we use logarithms and how we can solve problems step by step. So I got excited. So to cut a story short, I did well, got a division 1 with a 1 in mathematics at the time. And so I was admitted to A level, and I did mathematics, physics, chemistry, and I still got a principal in each one of them. So I came to University of Nairobi. I thank God. Then there was Professor Eshiwani. I'm sure now many of us will know Professor Eshiwani, may he rest in peace. And he also encouraged us to do mathematics and become teachers of mathematics. It was a very pleasant experience. So immediately I graduated, he actually asked me to come to Kenyatta University and work with him in the same department where I am now. While at Kenyatta University, that's when I saw a scholarship and went for a master's program at Harvard University, now to study mathematics education. And I'm very happy that in spite of that background, that we weren't rich, we didn't have money, God helped me reach this far. So I thank God for that, and I thank for the people that walked with me. That's the other point, that I feel I have a responsibility to walk with my students, help them as much as they can, as much as I can, so that they can also get to that level. Thank you.
Thank you very much. Same question to Dr. Sichanki as an introductory remark. It's okay. It's okay. Yeah.
My journey to mathematics education began way back when I was a primary school student. Apologies for that. A primary school student who thought mathematics was just one other easy subject like any other. And so I went through primary school very easily because I also was very close to my two brothers. It is until I got to high school, that time there was O level and A level, is when I noted a difference. When the mathematics teacher would be coming to class, I would see change of mood among my colleague students. And I didn't understand why. They locked the desk, they become sulky, and they looked like they were frowning. And I wasn't understanding. And then during the lesson, when I would raise my hand to respond to an answer, after the lesson, they'll jeer me down. Why are you showing yourself like you're the best in this class? Then I knew there was a problem. So I spoke with my father and my two brothers way back at home, and they told me that that is the subject. You can't afford to follow what your friends are telling you. Nobody in this home will not do mathematics. That's what my father and my two brothers told me. And so when I went back to school, I was determined to change the attitude of a few of my classmates. And so one of the things I did is to get a few, like 5, manageable, in Form 2. And I encouraged them to love their teacher of mathematics because I could see them very excited with the other teachers, but not the one of mathematics. And it was an era of caning, an era of you didn't finish your homework, so you step out of the class, maybe take a form of punishment. And that shaped my thinking about mathematics education. I even didn't know there was mathematics education. I just knew that there must be a better way of educating the children. And so I passed very well in mathematics, and my classmates, majority of them did not pass. So only the 5 or 6 children were able to pass out of a class of 45. And that left a great mark in my career life. So when I got to A level, of course I was in the science class, I decided I'll do maths, physics, and chemistry and ensure that mathematics is within my career. And I got a very good teacher at the A level, again, because you see, I was a darling of very many teachers because I did well. As long as you're a good student, you'll always be the good one. And so I performed again very well. But I asked him, is there a way I can get to the university and become a teacher, a different teacher that will teach especially the Form 1s and 2s and create a good perception towards the subject? He said, yes, in Kenyatta University, there is that course there. You can take education. And so I took education, double mathematics in Kenyatta University. I actually left the other subjects because I wanted to focus on this subject that is giving children problems. And when I was through the university, I planned to teach just for about 5 or so years. But I knew that there must be a way that I could reach teachers. My interest was to reach the teacher. First, change their perception and encourage them to teach well. And so today, as I do a lot of training, I do training of teachers in Kenya and Africa. I'm a very fulfilled mathematics educator. Reason, I not only train, but I also engage in policy dialogue forums with ministers of education. You are all aware that today's pronunciation by our minister makes a great milestone in mathematics. There is the role of policy and there is the role of practice when it comes to mathematics. And I can tell you, today, even if I retired, I'm a happy one. I've influenced
policy in Africa. I've influenced the development of STEM education policy in Kenya. Here we are about to publish it, and I was on the forefront. I have also carried the same format and encouraged ministers of education in Africa. I actually do a lot of policy dialogue forums. I go to a country, engage with stakeholders, and I encourage them that the reason why this subject is not being done well is about how you structure your policy and then the practice. And so today, that's a business I'm in, and I'm actually a very fulfilled person that we can support the course of mathematics. It's an important subject. It's a very, very easy subject. It's the only subject you change your attitude today, and tomorrow you have passed. Thank you very much.
Thanks a lot, Dr. Rinda. And as you carry on from there, in terms of when you look at the position as we are now, in view of the CBC, the interest for students to specialize, where are we coming from? What is the architecture of the current system? What gaps exist? And what are the things that we might get as messes or as we choose to make maths optional or not?
I must say from the onset, being a mathematics educator, that I will take the balanced view in regard to the both options. One, that it should be made compulsory, but two, there should be moderations when it comes to optional areas of mathematics, especially as we advance towards senior school. Now, I will start with the fact that the current competence-based education has made very good propositions in terms of the pathways. And when you look at the pathway where mathematics is pronounced compulsory is in the STEM pathway. And these STEM pathways stem right from preschool, when children engage in mathematics activities, and the focus is interaction. When you look at the curriculum, it says that the children should just interact with the concepts or learning areas at preschool and also with each other, so that they develop what we call interaction skills using the language of mathematics. And at that point, as they develop that language, when they get to primary, they now develop socialization skills. So every subject they learn, they must develop competence to socialize the subject to both their academia and their real life. And finally, when they come to junior school, they are now exploring specializations. They are not yet specialized, but they're exploring emerging specializations because they have been able to foundationally prepare themselves in terms of interaction with this subject, play around with the activities, and then finally explore which career pathways can come out of what I know. And when they get to senior school, they actually go into the specialization. And when you look at what the curriculum says, you find that the subjects have been classified in a way that they form a pathway. And under each of the pathways, there is provision now, based on the pronunciation the minister made today, there'll be provision for those students who take specialized mathematics and those who take a complementary level of mathematics, if you're taking the other pathway. To me, that is good enough. And the reason I'm saying it's good enough for compulsory aspects is because mathematics is the foundation of all the subjects we come across today. It develops logical thinking, it develops problem solving, it develops universality in terms of decision making, because if you are a lawyer and you're making decisions about your business enterprise, then you rely on the universality of budgeting, planning, and problem solving, because every career you encounter today, it has that component. And that is why I argue for mathematics being compulsory in whatever form. Then on the other hand, looking at the competences we are seeking as a country, it's important also to leave room for children that have talents in different areas, so that then they interact with some content of mathematics that is necessary but not their specialization. Which then in this case, if I'm going to take sports and arts and sports science, I will need specificities of mathematical concepts that are required in that field. And therefore, at that point, I may just need basic mathematics, so that then I focus and put all my energy in art and sports science. So when you reach the level of senior school, there must be some level of specialization, just like the way we did in A-level. Thank you very much.
And Dr. Florence, do you think it is important for students who are not interested in taking STEM courses to continue taking maths, or are we just creating bottlenecks and barriers for students in their career?
Thank you. Mathematics is life. And what I mean by that is that everyone in this planet needs mathematics. Whether you are cooking, whether you are digging, whether you are cleaning, whether you are cooking, whatever it is, you need mathematics. Because you need to reason. Do I need to do this? Is this the best one? I need to measure salt. We were making fun earlier that even our parents used mathematics and they hadn't been to school. They would put salt on their hand and know how much will fit the food they are cooking, for whether there are 10 children or 5 children, and the food was fine. When they are making ugali, they did not necessarily measure with cups the way we do now, but they put the right water and the right flour. So mathematics is life. And it inculcates reasoning, problem solving, and all of us have to reason out something, even making a decision. This morning, I need to do 1, 2, 3, 4, 5, but which one do I start with? Let me start with the clothes so that they will be drying as I clean the house. Or let me first go to the shop so that I buy what I need before I start doing something else. Isn't that reasoning? And that is the reasoning that comes from that process of problem solving, a mathematics problem. One of the things that I tell my students even now, I remember again from Mr. Moses, may he rest in peace, in primary school. He taught us to write at the end of the solution, QED. Capital Q, capital E, capital D. Quite easily done. And that was something to tell you that you can do it. And it worked well. Even now, I still do it to some extent. Quite easily done. So you are also telling yourself, yes, I can do it, and so on. So that step-by-step process of solving mathematics, like when we teach, we tell students, you start by asking yourself when you have a question, what am I supposed to find? What is the unknown? That in itself relates to life. In every situation, you'll ask yourself, what do I actually need? I'm going to the village, what do I need to carry? So that's a very important question. And then the next question we ask when we are solving mathematics is, what am I given in this question that is related to what I need to find? Isn't that what we do in everyday life? Why am I going to that place? What shall I benefit from it? Is it related to what I do in my real life? I came here today because it's related to what I do, right? If it wasn't related, I would have said, they can do it. So that reasoning part, and then the third part in the problem-solving strategy is then, now that I know what is related to the one I want to find, what is the relationship like? When now we write the equations that relate what I want to find and what I am given, then solve the problem. Then when I finish, if I was looking for the speed of a lorry, but I had been given, it reached Kakamega at this time and had started from Mumias at this time, and it took so long and so on, and I was going to find the distance of the lorry. Now I know how they are related. And then I remind myself, what is the formula? Speed is equal to distance over time. So we teach formulae because, again, there are things that you need to know as you go through this process. And then the final step, and I consider that for me very, very important, Yes, I've calculated and I've got the speed of the lorry. Do I stop there? We were taught by Moses, go back, look back, and we still teach that through George Polya. Go back. Does it satisfy what you wanted to find? So you're not just satisfied to submit the solution. You look back. Is this solution that I have satisfying what I needed to find? And if it doesn't satisfy, then go over it again. Isn't that what life is about? So those reasoning processes, for me, are developed through that mathematical aspect. Not necessarily the very complicated mathematics at university level, those of us who did the MPC and so on, but up to secondary school, mathematics is very important. And finally, one argument I always put is, why do we give identity cards at age 18? Why aren't they given at age 15? They are not given at age 15 because it's expected that your reasoning capacity hasn't matured to be able to make reasonable decisions and so on. That's why you get an identity. And therefore, in my view, stopping mathematics at age 15, which is grade 9, because I mean that is what it was going to be if we want to go on to going to take it to senior school. You are telling a 15-year-old that they don't need mathematics in their life. That would be lying to them. Thank you.
Thank you very much. And Dr. Alice, you have mentioned your journey through mathematics and how you loved it at some point, and then you got into points where you realized it's very important, pertinent into some certain aspects of what you're doing. The question is, when you look at the aspect of delivery, how should we, what should be the discussion of delivery in this whole conversation of the optionality of mathematics?
Yeah. So I think it should be a matter of relevance, because once people realize something is important for them, then they start looking at it in a different aspect. So in a point where a student doesn't understand why is math relevant to me, which is why when CS Ogambo made his announcement today, maybe as we were saying, we were talking outside, maybe it wasn't couched by the media in the right terms, because it looks like he has given into popular opinion or pressure, while this is a reasoned course of action to now make it compulsory again. But I think knowing the relevance of a subject is extremely important. So and I think on the Nation, they said simplified math, but it should be like maybe applied math, so that the people who are in the STEM can do their kind of math, and then the others can do what is also relevant to their courses. And maybe just because there are some people here, especially if you don't have a younger sibling in CBC, you might be wondering what we are talking about. So just to say, the 2633 system we are talking about, there is a PP1 and PP2, 4 and 5 years. Then lower primary is grade 1, 2, and 3. Then you move to upper primary, 4, 5, 6. Then junior high goes to 7, 8, 9. And the senior school we are discussing now is 10, 11, 12. So that is the one where math is now the debate was about. And the pathways, there is STEM, which they have spoken about. But even STEM, where math is compulsory, has 3, do you call them streams or pathways in curriculum? The track. So STEM has the pure sciences, they have the applied sciences, then they have technical studies. So Dr. Nyamu talked of home science. That is part of STEM. It's considered you need to know the temperatures of the food. I mean, the culinary schools have to worry about those kind of things. Agriculture is part of the technical. And the beautiful thing about the CBC or the STEM is that a person doing technical studies can actually get a dual certificate. So you get that you finished Form 4 or I don't know now, grade 12, after 10, 11, 12, but you can also get an artisan certificate so that you come out being a mechanic or a woodwork or whatever it is you're doing. So I think the relevance of it matters a lot. And I'll give an example of my nephew who is in a French system, and he's only 16, but he spends 1 week in school and the other week in a garage. So he's attached to a BMW garage. So you are with the mechanics all week, and then the other week you're in school. So maybe we do need that kind of of back and forth where we're engaging with industry, so that now when a teacher comes to talk about math, I know why it's important. So even for me in social science, you know, when the students come and we are saying we have the SDGs, we have indicators to calculate. We need to know where we are placed on this and that index. Now it makes sense, now it's fun. But to teach math in abstract, I think has been problematic. You best would know that, who are in the mathematics education, that a lot of students rise and fall based on who their teacher is. She keeps referring to Mr. Moses. You know, how many decades have passed? But the impact he had is still there, which tells me that the problem is with content and pedagogy as well. And it's still problematic when you see the World Bank wrote a report in 2018, and our math proficiency is at 25%, reading at 20%. So we do have a problem. Yeah.
Thanks. It will be interesting to get to know the deep dive a little bit into the pedagogy aspect, especially for mathematics, even as we get into the next dispensation for the CBC. But Dr. Mary, there has been conversations, especially the proponents of the optionality have been advancing the idea that, you know, we are doing very many complicated things. Where are we going to apply all this? So the approach is more of the service aspect, and there is very little, you know, we're not looking at the scale or the qualities that mathematics bring into this. What do you think about it? Perseverance, some of the qualities that you are able to get, problem solving. Should this be something that needs to be given more emphasis?
I think so. I think looking at mathematics purely from application is a very limited view. It is important. It is important that we are able to appreciate mathematics for its applications, but that is a very limited view of mathematics. And I think maybe that is why some people are seeing, when they're not able to see where they will use certain things. Somebody is asking themselves 5 years after they finished high school, I've not used Pythagoras theorem since I left high school. So why was I taught Pythagoras theorem? And I was not becoming an engineer. I think we need to consider other perspectives of why mathematics is important. And mathematics is important, I think, as my colleagues have already stated. There are other things that mathematics develops. But we also need to think about, go beyond just the applications and look at mathematics as a way of knowing. And I know that other disciplines also support us in knowing and understanding the world, but mathematics does that in a very, very successfully and in a way that permeates all areas of our lives. Mathematics, as some people have defined it, is the science of patterns. And mathematicians are always looking out for patterns. Even when you're looking for a solution to a particular problem, you're looking at that problem and you're trying to identify what are the patterns here. And in addition to looking for those patterns, as we look for those patterns in a particular problem, mathematics helps us to make the invisible visible. So sometimes when you're looking at a pandemic and you're looking at so many people are dying, the mathematician will be asking, so who are dying more? Who are the people who are more likely to die? What are the patterns here? And the mathematician will look at the data. And the mathematician, based on what we are looking at anecdotally, in terms of evidence, we're saying people are dying, like during COVID. The mathematician will then go study the patterns, and the mathematician will come up with a model. And the model will, and that is what happened, like during COVID. The models told the public that people who were 58 and above were more likely to get severe COVID when they got in contact with people who had COVID. People who had comorbidities were more likely to then die if they got severe COVID. So that bit about knowing, mathematics helps us. It gives us that ability to know our world better from different perspectives. It's something that we all need. And you may not be directly applying that algebraic formula that you learned, but mathematics gives you this ability in your mind to be able to process what you're seeing, to be able to identify patterns in what you're seeing, and then to be able to make decisions. But other than that, mathematics also has a creative medium. And there are people who are using mathematics and they are not aware that they're using mathematics. So when an artist is trying to represent something that in 2 dimensions, but he's representing that thing and it looks like it is in 3 dimensions, he's trying to put in depth in that 2-dimensional thing. That artist is using mathematics. The mathematician will call that projective geometry. The artist is thinking of it just as they're playing around with the perspectives. So they are using mathematics and they are not aware. And in my opinion, if that artist actually was aware that they're using mathematics and they collaborated with a mathematician, I can imagine that the work that they would do would go way beyond that drawing. I don't know. That's just my opinion. I'm just imagining a case where they are aware that actually what I'm doing here is projective geometry. And maybe if we worked with a mathematician, maybe we might actually do better. And so I believe that we should stop looking at mathematics just from a utilitarian perspective, but look at it more in terms of what does mathematics allow us to do? The kind of thinking that mathematics allow us to be able to engage in. I think we need to see mathematics from that perspective. And if we're able to see mathematics from that perspective, then we will stop. Actually, I'm saying this, and I have relatives who, because I'm in mathematics, they're always reminding me, you keep on saying mathematics is important. I've not used this particular formula that I learned in high school, but I believe very strongly that, yes, there is the part about utility, and it is important. It is important, but we need to think of the other things that mathematics enables us to do.
Okay, okay. Interesting thing about the known knowns, the known unknowns, and the unknown unknowns. Very, very philosophical. But I think there was something about the pedagogy, and I think I would also want to marry it up with what Dr. Mary has said, just about understanding the whole significance of maths. That we actually use maths inadvertently without knowing. But so, how should the teaching of mathematics be such that it makes students to see its value, but it also makes the students to love it? Mary or Florence, you can pick.
Can go first. Thanks. Yeah. On my way to responding to that question, I wanted to start with the discussion on whether it should be compulsory and link it to pedagogy. Looking at the Asian tigers, they discovered that mathematics was a very important subject. And so they started investing in maths and even STEM subjects. And today, when you look at their transition rates to the university, stand up above 75% compared to us, which is still at 25% into all the universities. That tells us something about our prioritization of the subject. So then it means the society needs to be educated, while in school, children need that subject to lay a very good foundation and also to strengthen for socioeconomic development and innovation. And where does that journey start? It starts in school. It starts right from preschool. And then the challenge we've always had is that we designate some of the teachers that you will not even want to mention the grade they scored to teach the little children. And so there's a weak foundation there. And they depart from focusing on helping the learner only to impart knowledge. And research has shown that actually teachers teach the way they were taught and not necessarily the way they were told to teach. And today we are talking competence-based education. Does the teacher know what it looks like? How do I practice competence-based education? It's a new phenomena that we must invest and help the teacher and also decide who teaches at the lowest levels of our education system. Having lived in a country like Japan for some years, I noted something about the kind of teacher who teaches at the preschool and the primary school. These are professors, yeah? A professor teaches in a university like this during the day, no, in the morning in the school, and then during the day in the university. So they have lessons at the university in the afternoon. Like my supervisor had a lot of interest in foundational learning. And so in the morning, you will not meet him because he'll be at school, teaching children at that level. And then in the afternoon, he'll come and interact with me. And then one time I said, for this semester, I'll spend time observing lessons in schools. And when you go to class, you find that children are actually enjoying mathematics. The teacher is just facilitating the process. He's well prepared, and that's why that society spends lots of time in planning and very little time on implementation. So that then they're well aware of the needs of the learner, the level of understanding, the content at hand, if it is abstract, if it needs more practical activities and hands-on. And so I spent a whole semester observing lessons. And I moved from preschool, they have a system like our current, and went to all the way up to a technical school, observing lessons. And I noted there's a difference in the way the teacher engages the discourse with the learners. And the learners are more excited to talk about mathematics. In fact, you see a lot of eureka moments, children excited about discovering the Pythagoras theorem and naming it by their own name, so that the teacher doesn't just walk to class and tell them, there is a man called Pythagoras and this is what he discovered. Instead, they lay out activities that learners explore, and they come up with a theorem, and they come up with that theorem and name it by their own name, before we now navigate to the formal definition of Pythagoras theorem, for instance. And so what we are saying, the pedagogy factor is a big issue in mathematics education. I can tell you, I've observed lessons on this continent. I research the classroom. That is my passion, because you can't inform policy if you don't research classroom. So I research classrooms. I spend more time in classrooms observing lessons, and it's out of that that you can now inform ministers on what kind of policy you need to develop. And that has made me understand that the difficultness of mathematics stems from how it is taught.
Okay.
And just to maybe touch on one other thing, why we need to allow little room for specialization, but using the example that one of us has given, I think it was Dr. Mary, why we need mathematics in all facets of life. The key here is quality lessons matters a lot at whatever level. And this can compel a learner to love or dislike, or just decide I'm not going to go that route. And so the quality that we inject both in resources and in the teaching process and in the innovations that can be used to teach make a whole difference. And lastly, perceptions. Because you notice in the class Form 2 I mentioned, it was perceptions about that teacher. He's coming, he's going to cane me, he's coming to check his homework. In fact, it was his homework and not our homework. So that the children did not own anything that the teacher brought to class. And so when he came, he was a source of anxiety. And the children just did not want to see him. And they would lock the desk, some of them lie on top of the desk. And this is what is happening in our schools, because I go to classrooms a lot. And so eventually you will ask yourself, you're making it compulsory, but what intervention do you make to ensure that that compulsory subject is being absorbed well?
Okay. So Dr. Florence, assuming that, and as you answer that question, you may need to add that what, all industries right now need mathematics, and I think that is what all of us are agreeing here. And how could we, or how can we prepare students who might not go taking advanced mathematics or mathematics at advanced level, so that they are prepared for this industry that is so mathematics centric? How can we prepare them?
Okay, thank you. I'll answer that, but let me first
Yeah.
respond to the earlier one. The most important part for me is the way teachers deliver the content in the mathematics classroom. And that's what I focused on in my PhD. I actually collected my data in 4 schools in Nairobi. And it was amazing. One teacher in one of the primary schools, I actually went to primary school deliberately because I thought the problems should start at primary school, and therefore let me go there and find out. And one teacher in one of the schools told me, you know, Florence, I was just given mathematics. I don't even know it, but I'm teaching it. So that taught me that there's a gap in the training of teachers of mathematics. What is it that we are wrong, especially even at that time, that makes these teachers say, lament? I was just told I must do mathematics, but I don't know it, and I'm teaching it anyway. That sense of helplessness is what I felt we need to get rid of. And there are many teachers today in many of the schools who I'm sure would say something similar to that. They may not understand the mathematics that is being tested, and that is why perhaps the students are failing. Because one of the things I keep asking, when you say that children have failed, who has actually failed? It is the teacher. Because the child came to you, came to me, so that they may pass that exam. The examination may have been difficult. I was in exams council for a long time. And we set questions that were difficult. But we always thought difficult in terms of what? You would think about the difficulty index and so on. So you balance in the paper so that you're testing the mathematics, not making it necessarily difficult. So that's something that we need to do. Focus on teacher training. Teacher training, make it more directed at the mathematics that they need to teach and how best to actually teach it. I have one master student who just turned in her proposal yesterday. And we agreed, now that she has been posted to a school in Nairobi, she can actually, and that school happens to be one of the schools I used for my study. I told her, you can even set up an experiment there using a particular type of method to teach the mathematics and give them a pre-test and a post-test, find out if it has changed the way of introducing that topic and the performance in that topic. So for me, focusing on the teacher training process is very important. I'll also say something else we've done in our department. The last 2 or 3 years, we said now we are going to make it more practical. So instead of just telling them do a continuous assessment topic in groups and so on, let's solve a mathematics problem from high school. So they sit like here and give them a problem and they solve it. I'm marking those just now for the cut. And it's amazing how different the ways of solving are. So it means it's like people went to different schools. For me, I was taught if you have an unknown, that's where you start. Let the speed of the bus be X kilometers per hour. That's where I start. So that then I look for what am I given and how is it related to this X, the unknown. So I set up equations given the information. Then I solve the equation. And when I solve the equation, I get the X. I haven't arrived. I go back. I say, therefore, the speed of the bus is 20 kilometers per hour. Because that was the question that was asked. So basically, I'm saying we need to hone down the way we teach mathematics in a way that learners can understand. Now ask me the next question.
I'll come I'll come back to you again. But let me ask Dr. Alice, should liking or struggling to do mathematics be an excuse for making mathematics optional, or the fact that there are statistics that are showing that we have close to is it 60-something% of people who failed? Should that be reason enough to make mathematics optional?
No, I think it was 72%.
72%.
But absolutely not. Now, with the current CBC as they go to senior school, I was seeing 3, and at least we have the experts here. But one of the things is an assessment of the students' own interests, but they also look at your track record, what you've been doing. So there are different ways in which you choose your pathway, not just your interest. They also have to look back. So we cannot move by public opinion, no matter whether it is the opinion of the parent or the student. There needs to be more analysis done. And if we are coming back to what she's talking about, pedagogy, that the problem is with the delivery, then that's what needs to be looked at. So definitely, if you give a 15-year-old a chance, they're going to not just drop math, they will do a lot of things, at that age. So of course, there is guidance needed, but we have to again question ourselves. Even as we are saying math is optional, and thankfully now it's differentiated between being applicable or not. But if we have already been having such a high failure rate, and if we are saying there is not enough teacher preparation, now we are fighting to keep math compulsory, but already we are seeing broken pieces. So I think we need to take a whole systems approach, ask ourselves with the delivery, what's the problem? Now we are moving from competency-based, from content-based, where you're just filling your brain with content, but also what's the disconnect with the labor market? Okay. Now, if we talk of utility, that math is needed everywhere. I remember President Museveni saying Shakespeare is not helping develop the country, so we can sit down and do poetry. So there are a lot of arguments for every, again, kind of discipline, but I think we need to look at the whole system from education to the development of the country, working our way backwards, even to the PP1. I looked at their curriculum, and it's so interesting and engaging. And I wish maybe we had that from the get-go. But let's take a whole systems approach, and not just with the failure or the interest and so on.
Thanks. I will be interested in getting just your brains in a few about the next steps before I'll invite the audience to get a few comments and questions from them. But Dr. Mwambi, a quick one. What do you see in terms of the costs? What are we likely to, the costs of what are we likely to lose, and how would the future look like if we are to make maths optional?
I'm sorry, sometimes I feel like I'm a maths salesman. I'm a proponent of more mathematics. I always feel like even the maths we do is not enough. we should be doing more maths. And so for me, now that the CS has made this announcement, it will no longer be optional. But if we were to go the route of having it optional, we would pay for it in terms of the time that we need to spend when they come to college and university. Because then they come in, they need to specialize in whatever training they want to do, and they don't have the requisite mathematical skills. So what do? Offer them maths courses, because they cannot do what they need to do before they do the mathematics that they need. And so the cost of that would be then that training at higher levels, in a sense, I don't want to say it would be compromised, but there would be need to now think of how do we accommodate these people who have come in, they need these extra maths courses. So it would interfere with the curriculum in university and in the colleges where these students are going to go to. And I just pray that if it does interfere, we don't get to the point like in the US where students go to the university, and if you don't have the mathematics that you need, you do it, but it is non-credit bearing, and you're paying for it. And I pray that that would not happen here. So the cost would be that somehow we would have to make adjustments, and it would cost us in terms of the time in the colleges and the university level. But for people maybe who don't go to college, then it means that they're missing out. As I said, that mathematics is a way of knowing. Mathematics is a creative medium. And if people leave school without enough mathematics, then it means that they're missing out on certain things. So for me, I think that would be a cost. But allow me just to make a comment on the whole issue about teaching and pedagogy. I think we make an assumption that is not correct, that when people leave teacher training, they are ready to teach. When you get a driver's license, you're not an expert driver. You get better with time. And the more you drive, the better you become. But with teaching, it's not necessary that the more you teach, the better you become. You become better, yes, because you learn from experience, you learn as you reflect on your learner's performance. But I believe that, and I'm glad that Dr. Sichangi is involved in policy. And as you talk to policymakers, I think one of the things that we need to inculcate in our systems is a system of continuous learning for our teachers. Continuous learning and reflecting on our teaching. And I think Dr. Nyamu or Dr. Sichangi, you mentioned that. Reflecting and researching on our teaching. I think that is something that we need to encourage. We need to inculcate it so that as teachers, we are constantly reflecting on our teaching, what is working, what is not working, and how can we improve it. And again, moving away from a focus on, I think the Japanese, and Mary probably experienced this, the Japanese they have lesson study, and the focus of lesson study is really just building a community of practice where we hold each other accountable to support each other, to improve our teaching. And so a teacher, they will collectively prepare a lesson for a particular topic that we know is problematic. Prepare the lesson, somebody will teach it, it will be observed, they will sit down and debrief. And then from there decide, okay. And the focus is often on how did the activities support learning. And so I feel like as we think about pedagogy, we need to make that shift from moving away from a focus on teaching to a focus on how is instruction supporting learning. Yeah.
All right, thank you very much. In terms of recommendations, what do you recommend based on the, of course, I know there are already non-confirmed reports about the direction government has made, which I'm sure are still going to, there's still going to be further conversations around it. But what do you recommend as the next steps? Kenya, and as you answer this, remember Kenya is, everything Kenya does is anchored onto us moving towards achieving our Vision 2030 of industrialization and things like that. What is the best direction to take?
My recommendation is that we make mathematics compulsory to senior school. It's also going to cost us more, just to respond on the cost issue, because of the assessment. Alice touched on it. Assessing competence-based education is very expensive because you have to go beyond a grade. It includes the grade and also other aspects that come with learning mathematics. So one of the things we need to do is to make it compulsory up to senior school, but also give room for the other pathways that are not taking STEM to have mathematics that is also reasonable for them to prepare for their careers. And therefore that will cost us something. And at this point, I like to say that I've, in the recent past, visited a few junior schools during their prize giving days, right here in Nairobi. And I noted how they were awarding the children. I remember there was one student who had a very poor handwriting. And so they said, Chief Guest, we would like you to award this particular one because she or he manages time very well, regardless of his poor handwriting. And so that means a teacher must have taken time to assess that specific learner. And we gave the child a chance to speak. And when you listen to the child articulate how he manages time, you see a lot of mathematics in it. A child said, I make sure every time I'm expected in a venue, I go 15 minutes before. Is that mathematics or not mathematics? 15 minutes before. I ensure my parents drop me in school 15 minutes before. All these are factors that will go with compulsory mathematics up to that level. Because then we are interested in timekeepers, isn't it? Not necessarily that I have I'm okay with the handwriting. The other recommendation is that we develop the capacity of teachers continuously, because like Dr. Mary has said, a teacher is made in the classroom. They only come with theories of teaching from universities. But that does not say that we also don't do a comprehensive overhaul of how we teach at the university, because that's where the journey starts. Subject method. How do I teach mathematics from university in the context of competence-based education? So that then when they graduate, they have the principles of learner-centered teaching, inquiry-based learning, the contemporary methods of teaching, and the contemporary child. Because remember, the 21st century learner is a restless learner. There are learners that want quick fixes. In fact, I'm sure if they're here, they're waiting, finish quickly, we want to leave. You know, they are restless, and therefore you must target their attention span in a very, very innovative way. And that's why today we talk about innovation in teaching, not just an innovation in how we communicate and teach. And lastly, my recommendation is the learning institutions are a very important factor in competence-based education, because they create a supportive learning environment. Many times teachers of mathematics have said, our school has nothing, there are no resources. We can't think outside the box to teach a concept other than using the textbook. So then the schools should actually invest, and that's why I said cost will go higher. Schools need to invest in strategic resources that support mathematics education, and long gone should be the tradition that mathematics is only taught by a textbook. Mathematics can be taught in the environment. We can actually sit under a tree and learn a lot of things under a tree. We can count seeds, we can do all sorts of things.
Great.
Thank you very much.
Thank you very much. Dr. Florence?
Thank you very much. I think I'll just start from where she has left. Yes, we can learn mathematics everywhere. I remember in grade 3, I keep going back to my primary school, because for me, I think that was a very strong foundation. I still remember that we were taken out by the teacher that time. Moses hadn't come. He came when I was in grade 6. But there was another one who took us to measure using the ruler a distance from now where the school was to a place, to tell us now that is so many yards, and therefore this represents this length. And I've never forgotten. So the practical application where possible, because not everything is really practical, is very, very important. And therefore I want to support my colleagues in saying we must rethink teacher preparation, teacher education. What kind of teacher is needed for CBE and for the 21st century? We are already doing that at KU. In the School of Education, we are aware we are going to get CBC students in 2029, and therefore we've already started. In fact, the dean called me just before I came here, so that we start now getting ready with the curriculum and also with the materials that we shall need, because we shall get a different crop of students, in 2029. And the last point I want to say is that one of the things we must remember is that we are not educating the children in Kenya for Kenya. We are educating them for life. We are educating them for the world. Our children, our grandchildren, and their children, and so on, are citizens of the world. And therefore, we must give the right background, strong backgrounds, so that if they go to Japan, even when they're in primary school, at that level, if they are lucky to be there, they are fit. And what they were taught in Kenya is not necessarily irrelevant. And that's one of the things we must focus on. Let's not, and I'm glad that the CS this morning, I was very happy about that discussion, that they came to our side. And that confirms what we are saying, that mathematics is universal. You don't want to train a child in Kenya, they haven't done mathematics, and yet you can't admit them to the university here, they go to Japan, and then they realize they have to study a unit, and they don't have the background. That's even more frustrating. So I think as we continue with this dialogue, because it's a dialogue, it's a discussion, the important thing is to remember that our children, the future generation, are not like us. Their future is not now, their future is later. And therefore, we do our best to prepare them for that future by giving them that background in mathematics that prepares somebody to reason, prepares somebody to plan ahead, to even think through, to make choices. Yes, probability is difficult, but it teaches you that you make choices, and it can be taught in a way that it is understood.
Thank you. Thank you very much. Dr. Alice?
Okay, thank you. I think now, since the CS spoke this morning, the title of our discussion has changed from the cost of it being optional. So the cost of it now not being optional, and as both doctors have spoken about, is that then we need to bring the resources that are there. So the World Bank report I mentioned before had talked of teacher preparation, but also of resources. So if we are going to have applicable math to the certain, the ones who are doing social science or the other, of course there'll be a cost to that to see what is applicable to them. As Dr. Nyamo was mentioned, 2029 we get our CBC. But I think so far the conversation has been on basic education, until grade 12, and a lot of the policies have probably been a conversation among them, unless you are maybe in teacher training. But I think we also need to have that conversation. So at Strathmore, at least, we started our training on CBC preparedness. I think even from last year, we were being taught of multiple intelligences, different needs, and so on. So we're already on that preparation journey. And I would be amiss to also not mention that we do have a Masters of Educational Management within the social science. So the other thing maybe to talk about is at least the assessments with CBC have changed. So it's not just the grade you get in junior secondary or for example, the fourth year. So they also look at your performance coming up. But the other thing to also mention is inequalities. Because we are talking of preparedness, but if we look at Kenya, we are still a very unequal society. If you look at the educational outcomes in maybe the northern counties and what we have in the central region in terms of retention rates, transition rates. So we also need to look at that holistically, even as we look at these issues. For the people in policy, maybe to just mention, we have the report on the Presidential Working Party of Education Reforms from 2023. You can get it online. And it goes very well, even the policies which have been there for even pre-colonial. But since 1964, we have like 10 different policy documents. So where are we missing with the implementation of it? And also we have the task force on the realignment of the education sector, which is what now brought the CBC. So to see where is the policy implementation gap and to also watch the current existing inequalities.
Thank you. Dr. Mary?
I think for me, the place of mathematics in a developing country, and I'm really glad that the CS made that announcement this morning, but there's a lot that we still need to do, of course, with regard to pedagogy. And I would want to say pedagogy at all levels. I think right now we're talking about pedagogy, but we are focusing more on the school level. But the pipeline leaks even at university level. So those are some of the areas where we need to think about, we need to rethink how we are teaching mathematics at all levels. And I'm saying that because we need mathematicians. We need mathematicians. We may not right now be ready for it developmentally as a country, but opportunity meets those who are ready. And opportunity will meet us as a country if we are ready. And if we are really to be part of the fourth industrial revolution, as a country, we want to be a part of that revolution fully, then we need mathematicians because mathematics lays the foundations for technological innovation. And so mine is, we need to strengthen mathematics. If we're going to strengthen mathematics, we need to work on how it is taught at all levels, and especially at the tertiary levels. If the schools do what they need to do, and we manage to increase that percentage of from 25% to those who are transiting to university. Now, those who are making that transition to university, the percentage that make it for mathematics-related courses is less than 10%. I am in the Institute of Mathematical Sciences, and the number of students that are able to get a B+ and above, because those are the people that we target for our programs, we are looking at 10% out of the almost 900,000 students that do KCSE. Only 10% manage a B+ and above. And this 10%, we need them for mathematics-related courses. These are the same people going in for medicine, they're going in for law, they're going in for all these other programs. And we also need them for mathematics. So we need, and after we get them, we also need to teach them in a way that when they leave, they are productive and innovative in the places that they go to. So I'm speaking from a point of the need to also support the development of research in the teaching and learning of mathematics as a country. We need to support research that looks at how mathematics is taught at all levels. We need that support. Thank you.
Great. Thanks. This has been, yes. Yes.
Yeah, thank you, because that's something I wanted to say about now research, intensifying research, because research is continue finding out what is it that we are doing. And at Kenyatta University 3 years ago, we started a unit for the third years known as Instructional Research and Practice. And it's doing so well that the students have become interested. And the concept we are emphasizing, one of the concepts, is teacher-researcher, becoming a researcher as a teacher, focusing on action research, such that even in your own classroom, why are the students not doing well in what you are teaching them? Find out even their views about your own teaching. And we are getting very amazing results on how they would do it, because one of the questions we asked, we are marking the exams right now, is, what do you do if you found that the subject you are teaching, people are just getting below the pass mark that we expect? And they are devising all types of ways of finding out. So that continuous rethinking, that continuous re-looking at what we are doing is also very, very important. Thank you.
Thank you very much, my panelists. I think I now want to open up to the audience for any questions or comments that somebody may have. Yes, I will take the first two. Then there's, you can mention your name and you make the comment or the question.
Yeah, thank you very much, Dr. Magolo. I'm also actually a mathematician, though a backbencher. I have one question for each of you, but before I do that, the mathematics as a subject mathematics was actually one of my favorite subjects, having done MCB at A level. Maths was the best subject I had. I did a master's in mathematics education, computer applications option. But then when it got to now the practice, I practiced more as a computer scientist than as a mathematician. But of course, you've reminded me that I've always been applying mathematics here and there. So my first question to Dr. Alice, we know the issue with capacity in the country. In fact, we do have some of the best policies, and we do write some of the best policies. And as an example, I can give you, there's one presentation I attended where someone from Rwanda was telling us that they actually took a policy from Kenya and implemented it quite successfully, and that's why they were able to have very good pharmaceuticals. So the problem is not so much with...
I hope
Great.
I've answered your question. Yes.
Thank you very much. Alice?
Thank you, Dr. Magola. I think yours to me was on the issue of policy and the implementation gap. In one word, I would say governance. Because when we speak on the one, it was called the Douglas Odhiambo report for 2012, the one that brought about the CBC, and it was to realign education with our constitution of 2010, which is devolved, which means that even those other counties should be getting the same kind of resources and so on, even with the hardship allowance and all. But if we look at the resources we have, I mean, if you take even one Auditor General report, you can see how much resources are being wasted. We have enough resources to cover this. But the idea even of human capital, of trained teachers without jobs, of schools which don't have what they need, it's an issue of governance. So I would just put it in that one way, that's been problematic. The other issue of, if we are saying it's compulsory, will we force the students? Now, I think it's Today's Nation that also had an analysis that was done, and most students, I think 38 or 39% would choose to do social science, another 30-something% STEM, and then only 28 were choosing the sports science. So definitely we still have a gap. And then when you hear only 10% are getting a B+, so I think we need to incentivize it. And I keep going back to the idea that it needs to be applicable, which takes us back to the devil's advocate, Robert Yawe, who has spoken about integrating it. Does the means justify the ends? I'm of the opinion that it is. Because even if math had not been compulsory, I believe we can still have ways to make the learners competent enough that when they come in 2029 and find me teaching development, and they have to do economics, that I will be able to integrate that, and even probably pick someone who didn't do math, a bit more difficult, but still integrate them to what they are doing. My father also did carpentry, so carpentry uses a lot of math. You have to get the joints right. I mean, this is precision to a high degree. So maybe that is something we should look at now. For us, we say the opposite of competency-based curriculum is content-based. But I know, content was incompetent. So we have said it, but we do need to get back to our competencies as educators as well. I think that was my questions.
Allow me just to make a comment on the issue. I think the competency-based curriculum is just making the development of the competencies more intentional and deliberate. But if you look at past syllabus, curricula, there is always mention, especially in mathematics, they mention critical thinking, they mention problem solving. So it was there, but it was not explicit, and it was therefore there was no intentionality in ensuring that those competencies come through. And so now we are being more deliberate. So when we say, it can't just be either or, it's been there, but maybe we were not as intentional about it. Yeah.
I would request the person who asked about pension fund maybe to restate the question, but as you restate it, let me first answer the other one. There was the one on action research, and you said, yes, it's not true research. That is fine. What we are teaching is that you have to look back. You know, like the way I was explaining what we do in mathematics, the Polya method. At the end, you look back. What is it that I did right? What is it that I need to do better? Why did I get the wrong answer? And so on. So the instructional research and practice unit that we have created is to let teachers get that opportunity to know that in your classroom, you need to investigate what is not going as well as you think or as you expect, so that you don't need necessarily to go outside and do research outside. You can also collect data, because it's the process. You collect some data, you then analyze that data and use it to assist you to improve. So we are encouraging teachers and pre-service teachers to look back. What is it that I did wrong that made all these children fail at the end of the term? What should I do next term? Was it my way of teaching? Was it the syllabus itself? Was it that I didn't do any practical work? It is like rethink. And everybody, I think, in our lives now as adults, we have learned to always look back in a certain way. The decisions you are making, if I go this way, where will it lead me? If I go this way, where will it lead me? What are the repercussions? So we're kind of saying teachers become reflective teachers. Actually, that's the main purpose. Reflect on what you're doing. And I normally start that class with, what is reflection? Reflection is looking at yourself. Even when we look at ourselves in the mirror before we leave the house. Why do we do that? It's because we want to know how we look and how we shall look to the outside world. So that is what we are teaching in that unit. Make the teacher a reflective person. Think about, look back, look at what you are doing and let it make sense for you and also for those that you are doing it for.
Yes,
I think
yes.
that's really the main purpose.
Yes.
Not necessarily the rigor of the research, that we do and so on.
Very good, thanks. I know I'm getting,
The pension, there was something about pension, was it?
I think he mentioned the action research, and the other one was functional fun or something. The role of fun in teaching.
Which one?
Pension fund, I had something.
Gamification.
Not the gamification.
Yeah, that's yes.
Thank you, so I've finished.
So just do a quick one so that we know we have in the next 5 minutes we should be done.
Okay. Innovation in mathematics pedagogy. We normally propose 2 ways. Teaching from first principles, an example I gave earlier on Pythagoras theorem. Instead of telling the children about Pythagoras theorem, something that looks quite abstract, is to engage them in activities that could be gamified, like you're saying. Then they come up with a generalization. And from there now you can link up with the theory or the theorem. And then of course, we see in the competence-based education a lot of proposition in their designs on learning, organization of learning. There's that component that has come with that design, and they talk about organization of learning. And so we are thinking that that's simply interpreted that children need to be engaged. It's either a game, it's either role play, or modeling what the curriculum desires, but and giving attention to what the learners bring to the class, and then bringing out a rationale why they learn. In fact, that's why mathematics has always been considered abstract, because we are not relating to what children bring to class. So that is what we may call innovation, focusing on the learner and helping the learner to appreciate. Then if you allow me, I'll just touch on something that the gentleman talked about on resources. Maybe we need to operationally define resources differently, because sometimes people think a resource is purely the chemical for teaching a concept or whatever. Even the teacher is a key resource in a school. And so when we talk inadequate resource, you can operationally expand it to accommodate even the human factor. And of course, the material factor And in the age of technology, we can also look at some of the virtual resources available that the teacher may not be able to use or access simply because of internet. And that is why I thought we could also consider this as a factor. Recently, we conducted a study, I think 2 years ago, in 9 African countries on the status of STEM education. And we found out that number one challenge was actually resources. So we expanded the definition and said, what are these resources we are talking about? And once you expand, it becomes easier to now see. I could be having a resource in the school, but I'm not even able to use it. So I'm not even a resourceful teacher myself. So that's what I thought I would add.
Thank you very much. I want to give 1 minute to, she wanted to make a comment.
Thank you very much for the presenters, Dr. May, Dr. Florence, Alice, and Dr. Mary. My name is Stella. I come from the Office of Faculty Affairs. Other than that, I am a teacher, but a special needs teacher, or what we call homeschooling. So in this conversation, we have spoken about the subject, and I think the learner has been somehow put aside. So I bring in, or rather want to bring a discussion of the learner, and in this case, I would like to agree with Dr. Alice when she talked about assessment, especially assessment at the formative level, where we assess learners to determine whether the learner has difficulties in understanding numbers, or what we call symbols. It's called a specific learning disability, and it's called dyscalculia. That's what my daughter has. So I have struggled through the system, and have seen, we actually discovered that she has that problem very late. Now, the question would be, would this learner need mathematics? I think the learner needs mathematics. Why? Because we are preparing learners for the 4 C's: a critical thinker, someone who is creative, who can communicate, and I think who can collaborate. So despite the fact that the learner has difficulties in understanding the symbols, then now we go back to pedagogy, that we need to prepare teachers to identify learners who are having difficulties, and how do we address learners who have dyscalculia. Thank you.
Thank you very much. It seems like we are still going to find X. So we need to get used to finding X. But I want to thank my panelists for the great insights and the conversations, and the audience for taking your time to join this Knowledge Care for this week. Also want to thank the Communications Department under the leadership of Dr. Betty Ngala for organizing this. We are so grateful for those who are watching us online. We also thank you for taking time, and keep watching the Knowledge Care for more conversations on other thematic areas that inform policy and a national discourse. Thank you very much, and have a good evening.
Are we together, audience? Yeah. All right. I think we must say that this conversation is timely, not necessarily for CBC, but for all of us who are in the School of Life. Because as we have heard from our presenters, indeed, mathematics is life. You make calculations literally for everything that you do. Where you go, who you go with, what you do, where you go. I mean, we make calculations for everything. And for our students in the Institute of Mathematics, these are the future policy makers, decision makers, who are going to, steer Kenya forward. And we are teaching them for the world, as has been stated here very clearly. I wanted to call upon one of the students to come and please help us to give a token of appreciation to our presenters. I will just point at you. Please come forward. Yes, it is you. Come. Please come forward. Thank you very much, panel. We must say we prepared quite a lot. And then the dialogue this morning, the press conference and the information that was coming out was almost throwing us off balance. But still, we proceeded because this conversation is as dynamic as they come. All right, so you go on stage and give each one of them a token. Over to you. We can clap for her, no? Thank you very much, panel, and to our very good audience. Maybe the person taking the photo, I'll sit down so that you can take a good shot. You can come forward, yes, one by one. Yes, you can do one by one. Thank you very much. We'll be clapping as they each receive something. Thank you very much for taking your time. Dr. Nyamu, it's your turn now.
Thank you.
All the way from Kenyatta University. Yes, thank you very much. You can face this side? Yes, yes, yes. Dr. Karuri also. Thank you very much, Dr. Alice. Dr. Mary Achieng. Thank you for helping us organize the panel. This eminent panel was put together by Dr. Mary Achieng. Thank you very much. And finally, our very able moderator, who did not even declare that he has a physics background. Thank you very much, Dr. Sawake. Again, Dr. Sawake is working in the Center for Energy, the Energy Research Center. Again, they're using a lot of mathematics there in the applications for all the things they're doing, whether it is converting solar energy into what we are using these days, whether it is the system that is running the university on solar PV these days. So there's quite a bit of application. I want to end it here and thank you all very much. Let's give ourselves a Thank you very much, panel. Thank you very much. Good afternoon.
Nice meeting you.